then that's plus negative 9.8 times t, which we are trying to solve currently. So, solving all of this math and getting a value, we find that time is going to equal 1.48 seconds. So that goes up here in 1.48. And if the flow time is half of that, then we just multiply by 2, and we can find that the full time the rabbit's in the air will be 2.96 seconds. So that's already the first one done. How far does it go? It's crucial that we already did the first thing for this, because we already know how long it's going to be there, so we can use that for our calculations for the next component. So horizontal, I will quickly get this out of here. Horizontally, put a graph. X, V, A, and T. We know that it's going to start at 0, and we don't know where it's going to end. That's going to answer question 2. Its velocity, we haven't calculated that yet, but we're going to do that similarly to the way we did with the vertical component. Acceleration is going to be 0, which is impossible, but because in real life, because of wind resistance, but we're not calculating that here. So acceleration is 0, and the time is starting at 0 and will end at 2.96 seconds. So we figured out what this value over here was, the vertical part, by using trigonometry. We can do the same thing for the other value. We just have to use cosine. So we take 15 cosine of 75, and that equals 3.9 meters per second. So that's going to be our velocity, our starting velocity and our final velocity, because the acceleration is still 0. Okay, so now we can use a linear motion equation. X equals v naught